All right, welcome to a quick demo. Today we're going to be going over one-point perspective on these various objects that are facing the viewer. This is in conjunction with our space handout, so we've referred to some of these terms in class. The first part of what we're going to do today is just label these one-point and two-point perspective diagrams here. And so in class we're going to read through these terms, but I just want to reiterate this just so that we can practice some good learning. So the first thing is the picture plane. It's the flat surface that the drawing takes place on. So in this one-point perspective diagram, this would be the picture plane. Picture plane. All right. Horizon line is also referred to as the eye level. So it's that space where like sky and earth meet and it creates this flat line. Typically that's about where your head is floating in space. That's where the horizon line is in the far distance. So understand that's your horizon line. Same in two-point perspective as well. So working down, we've got vanishing point. In one-point perspective, your vanishing point, and I'll abbreviate it VP, is right here. In two-point perspective, you're going to have VP1 and VP2. So vanishing point 1, vanishing point 2. Orthogonal lines, just a fancy word for all of these lines that go and recede towards the vanishing point. And so I'm just going to signify one of these. I'm going to put a double line over it, and I'll call this an orthogonal. And then basically any other line that you see receding to the vanishing point, these are all orthogonals. In two-point perspective, these are all orthogonals as well. One-point perspective, you can see an actual diagram of this one here. So there's just one vanishing point that all the orthogonals go to. In two-point perspective, we have two vanishing points right there that all of the orthogonals recede to. So again, I've got basic one-point and two-point diagrams here for help. Lastly, we've got a few terms here that are just used for understanding what we're actually seeing in here. So scale and proportion, the size of objects relative to each other in the viewer. So as things come closer to you, they look larger. So this square is closer to the picture plane, so it's larger. And then you can say this square right here, because it's further away, it starts to appear smaller. And so because of that, we get this idea or this illusion of space through scale and proportion, as well as through overlap. And so you can see with overlap where this square kind of sits in front of this one, we get the sense of it being in front of. And that creates this sense of overlap, which again supports this illusion of space. All right, so these are our key terms. On our two-point perspective, we want to label them as well. Horizon line. This is our picture plane. We've got our vanishing points, and this is two-point perspective. Now, with perspective, you're going to notice if you have a flat plane, in the case of this square right here, basically what we're going to do is we're going to go for each of these corners right here. We're going to look for each of those corners, and then we're going to connect an orthogonal from the corner down to the vanishing point. From the corner down to the vanishing point, so on and so forth. Due to overlap, some of the orthogonals will actually be behind the actual plane, and so they wouldn't be visible, but we can still draw them back there just so we have an understanding of where those orthogonals would actually head to. All right, so let's move on to the learning piece for today. So this goes to our second piece here. Again, we can see we've got our horizon line. And then we have our vanishing point. So I'm going to put VP. There's only one vanishing point. And so what we're going to do is, you guys will likely have pencils. We want to draw thin lines just so that they're easy to erase. And so we're going to have a writing utensil. Again, you guys will use pencil, and then a ruler or some kind of straight edge. And so I'm going to look at our object number 1 right here. It's this rectangle. And I'm going to connect my 4 corners of this rectangle down to the vanishing point. So I'm going to connect these orthogonals down to the vanishing point. And so the first thing I'm going to do is I'm going to connect A, B, and C. D we're going to talk about a little bit later just because it's behind the object, and so its orthogonal will actually be hidden. Alright, so now I'm just going to start with A, so going from point A down to VP, and I'm just going to draw a very thin line. Don't really want to make it super dark, and you'll understand in just a little bit. So A connects to VP. I'm going to go to B. B comes down to VP. Again, just thin lines. And then go to C. And C connects down to the VP. Again, this is 1 point. This is all we're going to do today. We're just going to do 1 point perspective. I'll make A a little bit darker just so you can see that better. All right. The last one, so like we're starting to get this illusion. We can see like the lower plane of this rectangle as it is above our eye level. But the last thing you can see is because the surface, this front plane right here, is facing us, we can't see behind. We can't see that orthogonal that connects D down to the vanishing point. We're still going to plot it though, and so what I want you to do is take your straight edge, connect D down to the VP, and what we're going to do is do an implied line, and so this one will be a dashed line. And so this helps to teach us that this orthogonal is not actually visible. It's hidden behind this object. And so if this object were to actually extend from this location all the way to the vanishing point, we wouldn't be able to see that dotted line. It would be behind it. All right, so this is all we're going to do is first just connect our corners to our vanishing point. So I'm going to go on to our object number 2 here. This one you can see actually crosses the horizon line, and so I'm going to do the same thing. So I'm going to go, we got point A, B, C, and D. Again, you need to think about like which orthogonals are actually hidden. I'm going to label this orthogonal. Okay. All right, so starting with A going to VP, you can see here, because it's going up and behind, this orthogonal is actually hidden. So I'm going to go to B just so we can start a solid line. So B, there's nothing blocking it, so B goes straight to VP. I can go to C. C goes straight to VP. And so that leaves us with just A and D. So again, A and D, because of this perspective, this plane is closest to the picture plane. These two orthogonals are actually going to be hidden, and so we'll connect them with just dotted lines. It's important to have a very sharp pencil while you do this, just so you can actually see what you're actually doing. So we're starting to get a sense of this, like these objects that are receding back into space. All right, let's keep going. So I'm going to keep labeling these the same. So A, B, C, and D. If I connect A to the vanishing point, you can see it's behind the actual object. If I come to B, B actually is unobstructed, see, so it just goes directly to the vanishing point. So this will be a solid line right to there. C is going to be unobstructed, so it's going to be a solid line. And D is going to be unobstructed, so it's going to be a solid line all the way back. So again, all of these are unobstructed because it's below the horizon line. We can actually see the top plane and the side plane of the object, which is pretty cool. But then where the orthogonal connects A back to our vanishing point, you can see it's behind the object, and so it's not visible. And so that one we're going to put in a dotted red line. Again, just like short little dashes, helps us just to practice our diagramming so that we know that that line, that orthogonal, is not visible. Now, what I want you to do for this exercise is to continue to the other squares on this side, and then you can even practice with the stars by connecting any of the tips or corners of the star back to the vanishing point. After we do this, though, we're going to then move into creating parallel lines. And so one of the basic rules to create this illusion of perspective is that all parallel lines, so all vertical lines, will be parallel to each other, and all horizontal lines will be parallel to each other. And so the coolest part where this actually starts to look like a three-dimensional object, what I like to do is just kind of like hold my ruler so that it looks like it's parallel with the base of this top object here. And then I'm just going to pull it down a little bit and keep this line parallel with this one. After it looks, I would say, pretty good to parallel, I can connect those lines across. So now we have a bottom plane of this object. And then through that same logic, all vertical lines are parallel to each other. I can make a vertical line connecting from that corner and going straight up. And so I'm going to actually color these now just so you can actually see like the different planes. So like here's your front plane. That's the actual object's front, like the front of the box. Then we've got the bottom plane. I'm going to change these in a different line direction. So we got the top, or the front face, we've got the bottom, and then the side plane. And these ones I could go in a vertical direction. Now with a different color or with your pencil, you could actually erase your orthogonals and see this object. But for you guys, I'm just going to switch to a black marker so you can see this three-dimensional object showing up. So there's the back. Here's the front plane. And then I'll connect my orthogonals. Again, in this case, I'm not connecting my orthogonals all the way to the vanishing point because I want to make this object actually look like a three-dimensional form. So I'm trying to create a cube. So there you can see, because I connected all of my corners back to the vanishing point, I then created parallel lines. All verticals are parallel, all horizontals are parallel. I now have a three-dimensional looking form. Moving on to this one, I'm only going to see the right plane, so I can make this vertical parallel over here. I'm just going to kind of eyeball it, something like that. And then I'll just connect B to where that vertical line goes up. Looks like that. And then C to where that vertical line goes up. And it looks like that. So now I've got another object here. So this almost looks like a building that's kind of like crossing the horizon there. And then the last one, you can see, I can see the top plane here and I can see the right plane here. So again, all horizontal lines are parallel to each other. I'm going to make the edge of my ruler parallel to this edge right here. All all vertical lines are parallel to each other. So I'm going to bring my ruler over here. I want to make the edge of the ruler parallel to this edge right here. And I'll just darken up these lines and the orthogonal. So you'll see where your vertical parallel lines intersect with the orthogonal. That kind of describes like the corner or the edges, like where those lines would actually stop. And there you go. So here's a nice little cube. Again, you start with just this rectangle. We connect our 3 points back to our vanishing point. And then we repeat any vertical lines are parallel and any horizontal lines is parallel, and it creates this illusion of this three-dimensional form. What I want people to do is like first just connect all of your locations here, all of these points back to the vanishing point. Like do that as your step one. So connect it for all of these. Try to indicate the hidden orthogonals, so the orthogonals that wouldn't be seen. Do it for all the squares, and then try it for the stars. And then after you've done that, then I'm going to come around and work with you individually with creating your vertical lines that are parallel to each other and the horizontal lines that are parallel to each other, because that part might be a little bit trickier, and so like I want to make sure I can support you as you work on that at your desks. All right, that's where I'm going to stop this demo, and yeah, let's get into it. All right.